Hi everyone. Let's take a look at the following question. Number 7. A rancher has 1,000 meters of fencing to enclose 2 rectangular corrals. The corrals have the same dimensions and one side in common. What dimensions will maximize the enclosed area? Step number 1. Write down a let statement. So again, if you think about x, and if you add them up, that's going to be 2x. Likewise, the width is going to be y. So let 2x and y be the dimensions in meters. Now, if you think about the EOC, which stands for the equation of constraint, this means if you look at the perimeter, which is 1,000 meters, that equals to the sum of x and x and x and x and y and y and y. So if you collect like terms, this is basically 4x plus 3y. So again, that's called the equation of constraint, which we're going to use in a moment. Now, our goal is to maximize the area. And again, if you think about this, the area, which is right here, this is given by the length times the width. And the fact that the length is going to be 2x and the width is going to be y. So the area equals to 2 times x times y. Now be mindful here, you have to express area only in terms of x or only in terms of y. So one approach is to rewrite this in terms of x, which means if you go back to the EOC, the equation of constraint, you can isolate for y. So if you keep 3y on the right-hand side, but I'm just writing it in reverse, you can bring 4x to the left. The opposite of multiplying by 3 is to divide by 3. So y is going to be 1,000 divided by 3 minus 4 divided by 3 times x. I'm going to put a box around this. Let's use a different color. So we're going to plug this back into here. So now if you think about the area in terms of x, that's going to be 2x times 1,000 divided by 3 minus 4 divided by 3 times x. Now before you go through the same 3 steps, which are take the derivative, set it to 0, solve for x, you may want to go back and expand this. So this is going to be 2,000 divided by 3 times x minus 8 divided by 3 times x squared. So again, it's the same 3 steps. Step 1, take the derivative. A prime of x equals to 2,000 divided by 3 minus 16 divided by 3 times x. The second step is you set the derivative to be 0. And the third step is to solve for x. So again, notice you can multiply both sides by 3. So you can cross out the common denominators. You can bring negative 16x to the left, which becomes positive 16x, which equals to 2,000. The opposite of multiplying by 16 is to divide by 16. 2,000 divided by 16, I think that's 125. So again, put this in a box, write down meters. You plug it back in. You can solve for the corresponding y value. That's 1,000 divided by 3 minus 4 divided by 3 times 125. I think that's 500 divided by 3. Again, I'm leaving exact form. And the final statement, I'll read it to you, but you can write this down, of course. So therefore, the dimensions are 250 meters by 500 over 3 meters. I hope this makes sense.